Welcome to my track. Let's see it. This is a seal. Yay! Sphere. Sphere.
Spheres.
Hey, save some spheres for me. Spheres. Hooray for spheres.
Hi guys! So, why did the beach ball do exactly what his friend told him to do? That's it! Sphere pressure. Alright, so these are the sphere formulas, okay? And they're pretty simple to remember. The surface area is 4 pi r squared and the volume is 4/3 pi r cubed. Okay, so these really aren't that bad. And so we're just gonna calculate this once and then we're gonna call it good because these really are pretty simple. So if I look at my beach ball, okay, if I look at my beach ball, the radius is the only figure that you need to know. Okay, and the radius is from any point on the surface of the sphere to the center. Okay, and the center is just like the core. Okay, so the very center, any point around the surface of the sphere to the center is the radius. All right, so we're just going to calculate this, and my radius of this beach ball is 6 inches. So we're going to calculate both the surface area and the volume, and you're going to see it's very simple. So the surface area here is equal to 4 pi times radius squared, so it's times 6 squared. Okay, so 4 times pi times 36. Okay, so that's 144 pi. Okay, and this is going to be inches squared because this is surface area. So this would be like if I cut all of these pieces, these sections out, and I flattened them out and laid them out, that would be the surface area. Okay, so 144 pi, and so then I can round to the nearest whatever. 144 pi is 452.4 approximately. This is approximately equal to 452.4 inches squared. Okay, so you just need to pay attention and see if the problem is asking you for your answer to be in terms of pi or rounded to the nearest something or other. Okay, so there's surface area, easy enough. All right, now we'll go to volume. Okay, volume equals 4/3 pi times radius cubed, so times the radius, which is 6 to the 3rd power. Okay, and so you can multiply the number by itself 3 times, or you could just go 6 to the little caret to the 3rd power, okay, which is 216, which you guys all probably knew anyway. So the volume is equal to 4/3 times pi times 216. Okay, and then you can multiply this however you want. You could go 216 times 4, which is 864, and then divide by 3, and you would get 288. Okay, so the volume is equal to 288 pi, and then it would be inches cubed, because that's, remember, the volume is 3-dimensional, so you can think you're going to put a 3 there for 3-dimensional. And then if we're going to figure out in terms of pi, okay, 288 times pi is approximately 904.77 yada yada, so we're going to say 904.8 inches cubed. And this is totally painless. That's it. That's all. Okay, we are going to do a couple of things where we go backwards, but this, you have the basics of spheres. And now we're going to go into one more thing, and then we are basically done with this chapter. Yay. So the last thing that we're going to talk about with this volume and surface area chapter is something called cross sections. Okay, and a cross section is like if you would slice the solid into two pieces. It doesn't have to be exactly in half, but if you would slice it, then you would see the cross section. And I'm going to give you a couple of visual representations, and then I'm going to show you a couple pictures. All right, so just think of this as a rectangular prism, these graham crackers, okay? If I would slice this rectangular prism somewhere along this side, okay, so let's just pretend I'm going to slice it, and voila. Okay, the cross section is this rectangle, okay? So if I slice it this direction, then I see a rectangle as the cross section, okay? So there's a rectangular cross section. All right, and then let's say instead I'm going to slice it right here, okay? So, ooh, look at that. All right, so I sliced it here, and here this is parallel to this base, okay? Not this top face, but the bases on either side, okay? So we get a cross section that looks like this, okay? So that's a rectangle, and that is parallel to the base, so it's the same size as the base, okay? The other cross section that I did this way was parallel to this base, and so we got something. I'm gonna do my best here to pick this up. We got something that was equal in size to the base, okay? So that's the cross section. All right, what do you imagine if we sliced a sphere in half, any direction? What do you imagine the cross section would look like? Yeah, that's right, it would be a circle. Okay, so it's a circle. All right, how about this triangular prism? If we slice it parallel to the base, what shape would the cross section be? Yes, it would be a triangle, okay? Now, imagine if instead we sliced it right here. If we slice it down here, what shape do you feel like that would be? It's a rectangle, okay? And I'm going to show you some pictures to make that. I can't cut through this because that would not go well, but I'm going to show you a couple pictures in a minute. All right, how about, let's go with this cone. If I just slice anywhere parallel to this circular base, what is the cross section going to look like? What shape? It's parallel to this circular base. Yeah, anywhere that we slice, you'll get a circle, okay? What if instead we slice it down the middle through that point? What shape would you get? Yeah, you get a triangle. Good. Okay, now we're gonna look at a cylinder, okay? And you know that if you slice directly down parallel with that base, you're gonna get a circle, right? Okay, but let's do a couple other ones, okay? What if we sliced down the middle here? Okay, so we make a slice down the middle. What is that cross section gonna look like? Then it is going to be a rectangle. Okay, if you slice a pyramid down the center, pardon the sound effects, you are going to get, what's it gonna be? A triangle. The last one that I want you to think about is if you slice a rectangular prism diagonally from corner to corner, what would that look like? Yes, it would be a rectangle. But how would you calculate the dimensions of that? Look at this. I mean, this is longer than the side. We made a triangle here from this point to this point. Oh, let's see if that's right. Yeah, good. Okay, so this right here is like the hypotenuse of this triangle. And this edge here is equal to this edge here. So you will actually have to calculate one of these later. But good job. Yay for cross sections. Woo! Good job, guys. Excellent work.